Well, this video is going to be a little more theoretical. We're going to look for a way to find maybe a formula where we can compute the future value of an annuity without having to add up every single number. So, in the previous example, remember we added 5 values together to compute the future value of the annuity. We had 1,000 plus 1,000 times 1.07. This one was compounded once, this one was compounded twice, this one was compounded 3 times, and this one was compounded 4 times. So this $1,000 represents the very first $1,000 in the sequence of 5 $1,000 investments. And that was added up to $57.50 and 74 cents. Well, suppose this weren't a 5-year annuity, but it was a 20-year annuity. 20 payments made over 20 years means we'd have to add up the same first 5 terms, but then we'd have a 6th term, a 7th, an 8th, all the way up to the last one being 1,000 times 1.07 to the 19th. So this is 20 terms we're adding up. You can think of this as the 0th term, and the first term, that exponent would be 1, and the second all the way up to exponent of 19. Well, that will be a lot of adding. So maybe there's something we can do to come up with a formula to add up such a sequence of numbers. Let's derive a general formula. We'll consider the original equation. And once again, I'm just going to write down what it, maybe I won't, I'll leave it. We know it added up to $57.50 and 74 cents. But let's take this and pretend like we didn't know what it added up to. Let's take this and multiply both sides of the equation, a is equal to this, by 1.07. So we're going to get 1.07a times a is equal to, and now I have to multiply every one of these terms by 1.07. All that means is I have to take the exponent and increase it by 1. So here the first one is not multiplied by 1.07 in the old equation, but in this new one, we have to multiply it by 1.07. The next one, this one right here, if we multiply it by 1.07, we just increase the exponent to a 2, plus to the third, plus 1,000, times 1.07 to the fourth, and then the last one, plus 1,000, times 1.07 to the 5th power. So this is equivalent to this because we multiplied both sides by the same thing, 1.07. Now, this is our new equation and this is the original equation. Subtract the original equation from the new equation and see what we get. So remember, if you subtract an equation from another equation, you get another equation, a third equation. So maybe I will write this down one more time right below it. A equals, and then that's 1,000 plus 1,000 times 1.07, and then this term plus 1,000 times 1.07 squared plus 1,000 times 1.07 to the third plus 1,000 times 1.07 to the 4th power. Did I get all of them? 1, 2, 3, 4, 5. Yep. Okay, so subtract the original from the new equation. Well, I'm going to ignore this 1,000 first for a second and notice that this minus this gives us 0. That cancels out. This minus this gives us 0. That cancels out. This minus this gives us 0, and that minus that gives us 0. So much of this canceled out. So the left-hand side would be, and maybe I will write it right here, 1.07a minus a, right? We're subtracting, so this minus this is equal to, and all that cancels out to 0. So we have this on top, which would be a positive 1,000 times 1.07 to the 5th power. And this is on the bottom in the second equation, so we're subtracting, so that's going to be minus 1,000. All right, so it's already getting more simple. Now, let's continue. Let's factor the left-hand side and then solve for a. So I'm going to write right here, I'm going to factor this. Notice A is a factor in both of these two terms, so I'm going to pull it out. And it's going to be 1.07 minus 1, because the coefficient of this A is just minus 1A. 1.07 minus 1. That is equal to 1,000 times 1.07 to the 5th power minus 1,000. Okay, well, what is this equal to right here? That's just 1.07 minus 1.00 if you want. This is just A times 0.07 equals, I'll go ahead and write it again. All right, so now to solve for A, we need to divide both sides by 0.07. So maybe I'll write that down. Divide both sides by 0.07 to get the following. A, that'll leave A by itself, equals 1,000 times 1.07 to the 5th power minus 1,000 all over 0.07. Great, that's what we wanted to do. Now, we'll generalize this in the next video, but look how simple this is. This is equal to this plus this plus this plus this plus this. So it's 5740.74. Now that may not seem like it's significantly more simple than adding up the 5 numbers, but suppose we wanted to add up these 20 numbers from 1,000 all the way up to 1,000 times 1.07 to the 19th power. The only thing we would have to change here is change that 5 to a 20. So it would be very simple to add up all of those 20 numbers. So we'll continue with this thought in the next video.